Okay.
My name is Rogelio Martinez,
Okay.
and he's Jason
Okay.
and Olivia.
Okay.
Okay, so the game that we decided is called Laser Maze, and well, so first we're going to go through the introduction,
Okay.
the game, and a little trial, the physics behind, and how we come up with the creation of the game. Okay, so Laser Maze for us is a captivating game that combines the strategic thinking, mastery of light manipulation, and time management,
Okay.
and safety first. Since we
That's
realized
important.
that lasers could be dangerous depending on the intensity and the amount of energy that they have. So
That's
why
right.
we have this. So for the game rules, it's pretty.
So here are the game rules.
So what's the name?
My name is Olivia.
Olivia. Okay.
Okay. So the goal is to hit the target, and players must solve the laser maze within 1 minute and get a bonus point if they achieve in a certain time limit. And the rules here is the laser must not be moved.
Okay. I don't understand, but go ahead.
So it's time for game and trial. So this is the map for level 1. As you can see the legend here, this is the target and the red one is the laser. So maybe we can get a volunteer or maybe a professor, would you like to play?
Okay. Maybe you want to try?
Yes.
Yes. Go ahead. Thank you for volunteering. Can you film this?
So what's your name, please? Sorry. Song. Okay. I'm Jason. Nice to meet you. So for this game, can you please come closer? So the laser is this one, which is the arrow there, and then the laser. Well, if you turn this on.
Uh-oh. Are you pointing to me?
No. There's a word already on.
It's already on.
It's already on.
Someone,
Sorry.
sorry, because it's dangerous.
So you have 4 mirrors. You have to line the laser to the target. But so if there's a type bonus if you do it under 10 seconds, there's a mirror bonus if you do it with 2 or more mirrors, and the recommendation is 1 mirror. So please, let's try.
I start the timer.
Okay.
1, 2, 3.
This is the target.
Yes.
Yep.
You have 10 seconds, no? Oh, okay.
Yes.
Oh, good, you're doing
Is this-
good.
Yes.
Okay, very good. Yes.
Oh, okay. Success. So,
So Song here gets 2 points because you did it under 10 seconds.
okay.
And I use 1 mirror. This is it anything like
Oh,
it was
it's good. Yeah, you get bonus for doing it fast.
okay.
Okay. Here's the map for the solution just now. And the next one is level 2. If you do it under 30 seconds, and it will get a +1 bonus point. And if you do it with 3 mirrors, it will get +1 bonus point. The recommendation is 2 mirrors.
So your rule is that saying using one mirror is more recommended because it can more points.
Yes.
So it's more creative when you do it.
Shall we invite more students? Do you want to try next? Please. What's your name? Yeah. Who? Okay, please come quick.
So we're going to do level 2. So we move the target in this case.
Okay, I'll start the time. Are you ready?
10 seconds.
Can you?
It's actually 1 minute, but if you do it in under 30 seconds, you get bonus points. So it's okay if
Okay.
you do it 1 minute.
You use 2 meters to hit the target. Okay.
1, 2, 3.
Go.
Goodness.
You can use 32, right? How many you can use?
You can.
You can use as many as you
Oh.
want. Yeah.
3 mirrors, you get bonus points.
Mhm.
This is
Yes.
yeah.
Okay. The time is 38 seconds, so he got the bonus point. The
How did
mirror.
you go? Did you use 3?
Yeah, it's 3.
So how does it go? 1, 2, no?
Oh,
Oh, that one is not right.
Yeah, this one is not being
It's not real.
used.
okay. So
So it's 2.
Yeah.
Is there a way to use 3 mirrors now?
There is.
Yeah, there is.
Ah, you can do it something like this, right? You do it something like this, right? You go.
What we do is we do this, then here, here, and then reflects to here.
Ah, that's good. Okay, thank you very much. Yes. We have more levels.
here's the solution.
Okay.
There is
Oh, okay. I think we already gave you the solution for level 3. So level 3, what we do is to add a layer of complexity to the game is that we add
Level
some
3, please. What's your
we
name?
add some walls.
Come quick. Yeah. You ready?
Okay.
okay. 1, 2, 3.
Wait, this is
Oh,
the target.
Yes,
Yes.
that's right.
Let's reset. 1, 2, 3.
It's turning.
Oh.
Yeah, sure. Oh yes, very good.
Oh.
Good job.
Good job.
The time is 32 seconds, so so he got 2 bonus points there.
We got bonus point for making it in less time and also for coming up with a creative solution using more mirrors.
Okay.
And this is the solution. If you notice, actually, this is same as level 2 without the bar. So it's another way that you can do level 2 using 3.
Oh, okay, okay.
So we're getting to the physics behind of this game.
Good.
So the first concept we're going to discuss is light. So light has different properties. The first one is that light travels in a straight line. Unless it interacts with an object or a medium, then it will do such a condition where it does reflection, refraction, or absorption. Reflection is the condition where the light bounces off a bouncy surface like a mirror. And then refraction is like a condition where the light goes through a medium. And absorption when the light is absorbed by a medium. And then the speed of light we know here is 2.99 times 10 to the power of 8 meter per second in vacuum condition.
Okay.
So we get it from the formula of speed of light equals to 1 over root of vacuum permittivity and times magnetic constant. Therefore, we get the number of speed of light.
Okay, Jason, why it is mu 0 times epsilon 0 square root is speed of light? Why is it?
Because it's in a vacuum condition and there's a magnetic constant that acting on the light.
No. I'm asking this. So the first line, speed of light is b equal 1 over square root of mu e epsilon 0, right?
Yeah.
Where did you get that?
We get it from Wikipedia.
No, that's not okay. Okay, so could you add in your report how do you derive that?
Okay, sure.
That's your homework.
All right.
Okay. Because that's I taught in my class, so I hope you understood. That's I explained in the class, so it's kind of review. Okay.
Okay, Professor. Okay, next. So the next one is about the laser itself, because laser is like the derivation of light, right? So the acronym for laser is light amplification by stimulated emission of radiation. And the first laser was built in 1960 by Theodore Maiman. So laser forms by producing light through optical amplification, which stimulates the emission of photons in a gain medium. And then after that, it goes into population inversion. So what is population inversion? It is a condition which more particles in material must be in the higher energy state than in the lower energy state. So this population inversion produces a laser which is different than other light sources, which the light is coherent. That's why it's like pointing in a very narrow space.
What do you mean by coherent?
Coherent, so it's the laser is like focused. It's like in a focus space. That's why it's like pointing like very small.
Is it true? So, what do you mean focused?
Focus is like, so if you take a laser pointer, right?
Yeah.
So it's different from a flashlight and laser pointer, because laser pointers, like the thing is very small, if you see.
So if it's small, it's laser.
Not really. So it's so the laser itself can produce different colors because of the mediums, right? And then that's why it's called coherent. And then
Okay, what is the exact meaning of coherent? That's what I'm asking.
exact meaning of coherent. That I will check.
Okay,
first.
that's yeah. Second homework. Okay, you're getting a lot of homework. Okay, this is very important. Your game is about laser, right? You should know what is laser. Yeah.
Okay, next one is about optics and geometry. So the thing here is done by reflection. So the law of reflection has two fundamental principles, which is incident ray and reflected ray. So the incident ray is the incoming light, and the reflected ray is the upcoming light, and the angle of the incidence is equals to the angle of the reflection. So the geometry here plays a significant role in determining the path of the laser beams in these games, and the geometry of the mirror surface and the incoming beam angle dictate where the beam will reflect.
Okay. Okay, so Olivia, you finished?
Oh yeah.
That's it?
Yeah.
Okay. So when does the reflection turn the refraction?
Refraction is when
I'm not asking what is it. When do they switch? That's a homework.
Okay.
Yeah. Okay, Olivia, are you going to come back again, or this is all you are going to?
This is it.
Okay, then you should do very good job in your report. Okay, because right now your point is not so high.
Okay.
So please do good job in your report so that your score going to be better. Okay, go ahead.
Okay, now for the last part, I'm going to explain the section that is related to energy.
Okay.
So today we keep delving into the fascinating world of lasers.
Yes.
And lasers are known for being very precise and very powerful. And many of the effectiveness derive on some energy factors. So one of them is called wavelengths. So there's a relation between the wavelength and also the concentration of energy. And usually the shorter the wavelengths, the higher energy concentration, and typically. And this
It's always, not usually. It's
okay.
always, right?
Yeah, because it's like inversely proportional, right?
Yes.
So, and this unique property provides the laser with a lot of precision and focus energy, and that's why it's very common to see it in a lot of industries like medical precision, because medical industry and also manufacturing processes. The other thing is that when a laser traverse through mirrors.
Sorry, you guys. What's the name? Yeah.
So
Okay. Please be quiet. Don't talk. I mean, Rodrigo is speaking now. You should listen to what's he talking about. Okay. Okay.
So yeah, so I was saying that energy conservation relates to when the laser beam traveled through the mirrors. Usually, there's an interesting phenomenon. Unlike other energy sources, the energy of the laser beams remains constant as it reflects on the mirrors, and there might not be energy loss. And the energy loss that you may get is probably from heat, depending on the intensity of the laser. And this also makes laser very stable and suitable for its reliability and predictability when it comes to laser technology. Now, intensity is another critical factor, influences the laser beam performance, and higher intensity often means a more focused and powerful beam. And actually, this is very interesting because it results in reduced energy loss during the transmission because the energy is better concentrated, I would describe it. And also, the last part that affects the energy level is the beam diameter. And this is very important because this means that the smaller the diameter, the energy concentration over an area is bigger. And smaller beams diameters concentrate more energy, and those making it very potent and very precise for cutting, welding, or surgical procedures. And lastly, the way energy behaves in lasers is related to the laser medium. And this is one of the core elements dictating how the output is going to be. And it varies across different type of lasers. And also if the medium is solid, liquid, gas, semiconductor. And also this is going to affect the total energy output potential. So yeah, that's when it comes to energy.
Okay. So you mentioned several applications, right?
Mm.
What did you mention?
How the energy in the laser is related to wavelengths, the intensity, the diameter.
I'm sorry, application.
Application.
Oh,
I think one of and I have friends who have done it, is like the laser surgery for the eyes. That they
okay.
use lasers to pretty much do small cuts on the cornea.
Mhm.
And thus they are able to fix some like eyesight problems that some people may have.
Okay.
Mm.
So how the laser cut only the what you want? Because laser is going straight, right?
Mm.
But then you want to, for surgery, you want to only cut certain part, right? You don't want to, make a hole on human body, right?
Mm.
You say eye surgery, you put the laser here, and you don't want a hole into your head,
Yeah,
right? How do you adjust that?
So I think it's related to what I was saying, that the medium in which the laser acts
Okay,
and
so
the type of laser.
so it would be nice if you're talking about interesting stuff. It would be nice if you go more detail, if you go into more detail. So can you report more details of this medical use of the laser? And you
Yes.
also mentioned the semiconductor, right?
Mm.
So can you say, I would say 3 applications, and then can you go more detail?
For sure.
Oh,
For sure.
that will make your presentation better. Okay. Thank you, Rogelio.
So
Oh, okay, good. Jason, you're coming here. That's good.
So this is how we create the laser game. So
Okay.
for the inspiration itself, we got it from the mirror maze. So on a mirror maze, you get into a maze, but the walls are made of mirror. So we go to the target, but in this case, we use lasers instead. And then for the laser, we previously bought a class 3B laser, which was this strong. It's actually beaming.
Mhm.
It's scary, and we thought it was too dangerous, and we switched to a class 2 laser, which was a normal the laser pointer.
Okay.
And then the hardware itself, we use infraboard for the map.
This one? Yeah.
Yes, the black one. And for the mirror stands, we use clips, which is used for papers.
Okay, good. Laser mix, right?
Yes.
That's okay. That's good. So, okay.
I would like to add a little bit about the clips here. So at
Okay.
first, we didn't think that clips are working. Actually, we used another infraboard to make a 90-degree stance, and then
Mhm.
after we think about it, and we came up to an idea that maybe clips might work, and then
Yeah.
we try it, and
Good-
it works
good
90
idea.
degrees. Yeah.
It's working out. Yes. It's almost 90 degrees. That's a good idea.
And the next one is about the
Okay, let's do that. Oh, you guys are 3, so you guys have time to do Kahoot. That's good. So everybody, please join. Okay. What's the pin number?
It's still loading.
Okay, no problem. Can you also share the Kahoot screen for online people?
Okay.
I'm sorry, I lost the pin. Who's Kenji? Okay, Kenji is there. Who's Clam? Okay, you're there. Who's Seven? It's like sounds like a cyborg, you know? Oh, Seven is online. Okay.
Is everyone joining already?
Cindy, right?
No, leave it one more.
Okay. Seven is Cindy. Okay, Cindy. Oh, I remember Cindy is good at coding. So, okay.
So shall we start?
Yes, please. Let's do that.
Three, two, one. Quiz time.
I ran out of time.
Okay, next one.
I always do that. I don't know. Did you explain?
Yes, I did.
Yes, he said.
I don't know. Oh, I got it accidentally. Because I didn't know that guy who invented the laser, so the other guy I know, right? Einstein. So this is related to Jason's homework, no?
Yeah.
Did you grade this quiz? Did you grade this question?
Yes, I did.
Okay, then you know that's good.
Mhm.
Oh, Kenji is doing good.
Good job, Kenji.
Oh, this is tricky. The unit is different for you. I almost clicked the yellow one. The unit was different. I don't know if it's 4 or 3 or 5. Did you explain this?
Yes, it's actually have two, the considering the
Oh, okay. So the false is the correct answer.
yes.
Okay. Oh, cloud is coming out. Oh, everybody got it. Oh, this I remember Olivia was talking about.
Yes.
Everybody got it? Olivia, your quizzes are too easy. Oh, Yuan is doing good. Everybody got it. Eh? There are two answers, no? But frequency is the same thing. It's okay. We can learn from errors, right? So you know that, right? Wavelength and frequency is the same thing. You know, it's just 1 over c, right? Uh, yeah, but in reality, there's you lose some energy, right, in the reflection. Claude is the third. You want the second? Oh, good. Good. Okay, so Claude, you get a bonus point. Put Claude there, right? So just email you one, and then you get a bonus point. Congratulations. Cindy got a lot of bonus points. She was getting every week. So. But anyway, this week, Claude. Okay, so you guys are finished? Okay, thank you very much. So actually, this is exactly physics experiment for optics, right? When we build a telescope or instrument, we set up something like this, and then test the camera and things like that, filters, and then other physics experiments also use these kind of things, right? So actually, you guys are thinking like physics experiments. That's good. Okay, thank you very much. It's interesting and then good. And then please do your homework. And then shall we move on to the second group? Please write down your names on the board. I think you guys are the first one to finish within time. Good job. So the next group is group 7.
Yes.
Okay. Welcome to the final presentation. Kenji, I know Kenji's there, right? Napat, okay. Clown, you got bonus points, congratulations. And then Jojo, good morning. And then Hannah is here, okay. Good morning. Pakapu, okay, you're here, okay. And then so you're this. I don't know how to read this. But Yan Semaim, right? That's your name?
Yeah. A Chinese.
Yeah. Okay. Chinese
You
name.
can call me Song.
Song?
Just Song.
Okay. Like Song Dynasty, Song.
Yes.
S-O-N?
Yeah, S-O-N-C.
Okay. Okay, good. Okay, are you ready? Did you share the screen online? Can you join the Google Meet and share the screen?
Yes.
Good. Okay, I already let you in.
Maybe my internet is with.
Okay, could you mute on speaker?
Yes.
Okay. Your speaker and the microphone need to be on. The volume need to be there.
Output volume.
Yes. Okay, good. Okay, let's get started.
Okay, our game called Real Life Physics at Home. The reason we use this name because we try to use physics in our real life, and with our game concepts, you can create it by yourself. So you can make it at home. So how do you make it? So you just draw a board. Our concept is like a ladder snake. So just draw a board like a ladder snake, and you draw an event card. An event card is like you draw, you add a physics concept like there's suddenly the ice part. So you have to increase your friction so you can walk, something like that. And then you grab a dice and just play with your friend or your professor.
Okay.
So the game rule is be the first to reach the end of the board and use your physics knowledge from Professor Tomo class. So you can use the item wisely on each event and or be lucky with your dice.
Okay.
So this is an example of the
Very
like
nice.
the board with the ladder, and the star is where you will get item, and the this mark is where you will meet your event.
Okay.
So the event will be like in the pile like this, and you just draw it and read it. And if you have an item to counter this, like you see the ice part, like this, the ice part, it will be like have the description like this. You have to roll dice or get a point or more to increase your friction, or you just use the item to
you have
skip
item.
the event. Yes. Then we will introduce the physics we add in the game. Each of us have introduced each physics concept. So we will speak concept we have introduced.
Okay.
The first one will be friction.
So lastly, in the previous slides,
Sorry,
you
what's
see
your name?
ping. Shouldn't have one
Your
of
Pum, right?
ping. Ping.
The second last one.
Second last.
Okay.
Shouldn't have done that.
Small.
Shouldn't have done excuse me.
Not this, right?
Yeah, this one.
This one. Okay.
Yeah, this guy. Okay, so last previous slide we see someone will be sleep from trying to walking, but why? Why? Because first it's because of friction. As we know, the friction force came from the coefficient with normal force. Normal force, the force in free body diagram. We know we have the weight when we go into some of the mass that have the gravity or the acceleration pulling it itself. The normal force is force back force to balancing into hence they like we standing right now, we not drop out or we not like fly away. So the friction is the from the x-axis that we are trying to walking and they for trying to avoid us moving. So first is why we sleep, why we walk on the ice or we walk on the water and we can sleep up or we can fail into the injury. So first we need to understand that the ice makes from water. The water they have something like we call it's what the lubricant. The lubricant is mean they will like trying to like the medium, like we have ice and then we have our feet with our shoes. The water will be a lubricant that will be the layer that's reducing the coefficient. When the coefficient is reduced, it means that the friction is imbalanced. That's because we can. But actually, in the coefficients, we have two coefficients with its statics and kinetic. Okay. And next thing that if we know that we are decreasing the friction, and how can we increase it? So we can see in the previous slide saying like we have the item that we can avoid that is merely anti-slip shoes. So why? Because when the shoes normally the surface area they can contact to the material is have only a one layer. But in the anti-slip in the real life, you have a spike in the floor of the shoes that's increasing the thing that we call a surface contact area. That we can increase, they also increasing the friction, or when we are trying to walking on the place on the space that have the less friction.
So
you finished?
Yeah, and actually I have another one, but later.
Okay. Hope you come back. Okay.
So the next one
Your
is
Kenji, right?
yes.
Okay.
So the next one is about gravity and it's G-force.
Mhm.
So what is G-force? So G-force is like the measurement of acceleration due to the gravity, and it can affect us when we experience G-force. So to counter this, people usually wear G-suits, which contracts the what do you call it, the blood veins to prevent blood from traveling to the feet or like the hands.
How does it work? It is G suit.
Yeah.
How does it prevent blood going to the?
It contracts the end parts of our body from
It doesn't look so. It's very loose, no?
um yeah. The real application when they get in, they will type it in,
Okay.
because this is outside the plane. So if it tight all the time, it's gonna be not comfort.
Okay.
Yes. And then what is thrust? So thrust is like the forward force generated by like some machine parts. Yeah, like the engines or the rotors of the plane. And from the research, it follows the Newton's.
Ah, okay. It's gonna inflate. So the suits, when they use, it's gonna inflate. I put the pressure.
Yeah.
Yeah, you didn't explain that, no? What do you mean? Yeah. Okay, go ahead.
So it's like the action and reaction. So this is like the action in the Newton's third law. So and then thrust is like the product of velocity multiplied by the change in mass over change in time.
Mhm.
And an example is like the plane. So it has the hot air coming out from the propellant, and the hot air pushes the plane forward. Something like that. And then the opposite of a thrust is a drag. So, and then there are also factors that affect, like increase the drag, maybe like the shape of the object or like the air density. And then drag is the product of the the density of the fluid, and then the drag coefficient, and then the cross-sectional area of the object, and then also the velocity, how fast the object is traveling through the fluid.
So what is CD?
The drag coefficient of the
Okay.
fluid.
How is it determined?
Okay, so this is
So I'm
Yeah,
asking
yeah.
Kenji.
because it also he is like the introduction for the drag, and I will talk more about the drag in aerodynamics and
Okay.
Fluid?
Kenji, are you going to come back or you finished?
um, um like you mean during this presentation?
Yes.
Yeah.
What do you mean? Yeah. Are you going to come back or you finished?
Yes, I'll come back.
You're going to come back. Okay, fine. Okay, so let's go.
Okay, sorry for. So the the drag coefficients, we have to make our experience to determine it. So we move C in this part. So we divide the drag force we can measure with the reference area we have, and the the density of the fluid and the flow velocity divided by 2.
Mhm.
And this flow visibility is relative. So if we stand still and the fluid flow,
Mhm.
this is the V of the fluid will be that V. But if we also moving forwards, the V will increase since we moving the opposite side, and the relative velocity will increase. And so the reference area you can see here as a difference drag coefficient of each shape.
Oh, okay.
So
Your
we
answer here.
so we can use this to create something like an airplane, or make our car drive faster, or one of the famous thing in the world is Shinkansen in Japan also use
Mhm.
this principle to make that train can travel with high speed.
Okay, so I have a question. So now you show examples, but how do you actually calculate this? Say if you change the shape, how do you calculate CD?
So they have experiments
Okay.
in physics, some physics departments in some university.
Hmm.
There will be a flow tunnel. I
Okay.
didn't add a picture here, but in that tunnel you can make you can simulate the wind, so we can measure different shape CD
Hmm.
by using the equation here
Hmm.
and calculate it.
Hmm.
Then you can use that shape or material surface to increase or decrease your air resistance.
Okay.
Yes. You will want to decrease it if you want to increase your speed, like F1, car, airplane, train. But if you want to increase, like a parachute
Hmm.
or like a parachute to protect the spaceship, because spaceship have to fall down for really high, right? So we want really great dark force.
So
And then,
you need experiments to measure CD?
yes, we first measure CD with experiments.
Hmm. Doesn't this doesn't it depends on the direction of airflow? Because now here you're assuming airflow is coming from the front, but if coming from the angle, then the effect will be different in different shapes, right?
In that case,
Hmm.
the area of reference will be different.
Okay,
Like,
but then
the-
wait. But then the direction of the object moving is the same. It's moving to the left in this case, right?
Yes.
So how do you calculate the reference area?
The easiest way we use the trigonometry law to make a force become our x and y, and then calculate it. That way is easier.
So the area, so object is moving left. Is the area different or not?
If the airflow is different, right?
Yes.
That case, if we separate the force into x and y, right? The
Hmm.
force from y,
Hmm.
the airflow from y will be the same, but the force from x will be different.
Okay, so
Because
what
they-
happens to the reference area?
So this is the interesting thing in aerodynamics,
Hmm.
because the airflow will not stay the same direction as our movements. So when we calculate it, we have to consider the airflow with different direction. So it's become more complicated. That is interesting thing in the aerodynamics.
Okay, I'm asking how it's going to be complicated. So you said the reference area is going to change. Does it change or not?
Yes, because the reference area will change.
Even if it's moving in the same way, same
Yes.
direction.
With different airflow.
Are you sure? Okay, what happens if it's moving to the, how do you calculate airflow? Sorry, reference area. Can you show?
You mean the airflow?
Airflow how do you calculate?
So
You now said it depends on airflow. It's a function of airflow.
the airflow we have to integrate it, because the plane is easy because it's all the same direction, right? If it's circle,
Okay. Now
Yes.
let's make it your homework. Okay. When the airflow changes, direction changes, how does the CD changes? Can we investigate? Okay.
Okay, I will add it. Okay, and I'm sorry, and I will come back again later.
Okay.
Okay, I am Jojo. So I will talk in this part about the buoyancy. So usually the object, like if we place it in the fluid, it might float or it might sink. But how do we know that it will, which item will float, right? So usually, all the object it will have the weight or the mg, but when we put it into a fluid, it will have a force which is called buoyancy. So different items might have different buoyancy force where it can be derived from this equation where we have the low rho, which is the density of the fluid. So in general, if the rho of that object when placed in the fluid, if its relative value is less than the fluid, usually it will float, but else it will just go down. So let's take a look at this example. So you can see here this the weights of the stone and the feathers. Usually, if you just place it on the normal surface, it will have the equal mass, as you can see, because the scale is in the same level. But when you also place it in the water, even though they seem to have the kind of the same scaling, but actually the force that have the upward force that do to the object is quite different. Because for example, the stone being denser, so actually it's occupy less space. Then it displays a small volume of water when submerged. Then this results in a lower buoyancy force, which is insufficient to keep the steel to be float, causing them to sink. But we can see here feather, despite they have the same weight as the stone, they're less dense and they also occupy more space. And they also displace more water, so they create a greater buoyancy force. And actually, the fact that the feather is floating into the water is also might due to the less density and the air that might have the effect towards the feathers. Yeah, this is my part.
What happens if you put it up?
If you pull it up, because assume that it is not wet, okay, then if you just pull it up, it will also have the same scale because assuming that this object A and this object B, they have the same mass, so they have the same mg. So they must have the same upward force in the ground, on the ground.
Okay, so right now it's the same, right?
Yeah, it's
you
also
put
the
it
same.
out, it's the same.
Yeah.
Okay, you're wrong. Okay, just report in your homework. Okay,
Yeah.
you're wrong. Okay, and also, okay, just calculate how does the iron ship is going to float. Okay, how big it needs to be. Okay, you assume a cube, empty iron cube.
Yeah.
Okay, you have or maybe stone is fine. Okay, the wall is 4 centimeter thickness. Okay, cube. Okay, inside it's empty. Okay, the wall is 4 centimeter. And you put it in the water, does it sink or float?
The stone.
Oh,
Yeah, it will sink.
really?
But yes.
So, okay, you have a ship, right? Iron ship.
Yeah.
Boat. It's iron, right? Does it sink?
No.
You should just sink, right? Okay, the homework. Okay. If it's small, it sink. When it becomes big and then buoyancy gets large enough, it's gonna float. Okay, please calculate how big it needs to be. Okay, this is the homework I presented in my class. Okay, so if you're listening to my class, you should be able to do it very easily, right? So please do it in your homework. Okay, this is too easy. You need to go deeper. Okay, this is university, no? Right? So, 加油, Jojo. Okay, next person.
Okay, this part I come back again. So
Okay.
about the sound, what is a sound? Sound is also the waves, but it's a bit different from the light or the electric because the sound is a longitude wave. So the normal wave will move like up and down like this, right? But the
Okay.
sound will move forwards and backwards. As you can see here, it's the amalgam that's compressed and released.
Okay.
That's create the sound. So if you have tried like a white glass and you tap a bit of water and circle around the edge, it will start to rotate resonance a bit and gradually it will create a sound. So sound is like when you resonance the air with certain frequency, then it will create a sound with that frequency. The higher the range, the reference, the higher the pitch of the sound will be. So talk about the harmful of the sound. Maybe you have heard about if you listen to the sound that's loud for too long.
Oh, okay, you did skip easy part. So what are you talking about there?
It's about how our ear receives the sound.
Okay.
The inner bone, and the eardrum and the ear cell here in our ear. There are two type of harm that it may affect you. One is your eardrum. If it's suddenly loud noise, your eardrum. Remember the sound is resonance, right? So if the eardrum is resonance too fast, because it's also the object, you may have seen the glass that is break because the opera singer.
Yeah.
So it's similar to that situation. So your eardrum may be bust because the loud or too high pitch sound with a long time.
Okay.
And the inner ear is a cell with like a brush. So if you heard the sound too long, that brush may be spread around, and this is we call the damaged ear cell. This is the harmful of the sound.
So which one is going to happen? So you mentioned two, right? So which one is going to happen? Say if your normal conversation, if you continue 16 hours, what's going to happen?
So this one with the long range of the like constant certain of decibel, usually the hurt one will be the ear cell, the one like a brush,
Okay.
and the one that will hurt your eardrum is like suddenly like explosion or like really high pitch with like suddenly come, something like this will hurt your eardrum.
How does it depend on the hours? So so we do normal conversation, right? Like this conversation, right?
Yes.
So if we keep talking 16 hours, our ear is going to be damaged.
This graph is a warning, like it may hurt you. The reason is because as we keep listening to the sound, right, our ear cell here, like the brush, we keep resonant, right? So the cell have the limit. Every material have their limit.
Okay, so
Yeah.
so I'm curious why you have hours there. So can you report in a report that how does it damage changes as a function of time? Okay.
Okay.
Why and then why? Explain why.
Yes.
Okay. I don't know. I don't know why it depends on time. Okay, let's go. Next. By the way, you guys have 10 minutes, okay? Please be careful.
So this one is about the resistivity. So we have one of the events where it's about electricity, where you get shocked by an electricity, and we have to find a material to counter it. So it's about like conductivity of a material. So conductivity is like the ability of the material to conduct the electric current. and the resistivity of the object is the resistance multiplied by the cross-sectional area and the length of the over the length of the material.
Yeah.
And then materials are separated into three main types, so like conductors, and then semiconductors, and then non-conductors, or like the insulators.
Hmm.
And conductors is like the material that is that can conduct electric current, like is very good at that. And then the semiconductor is like it can conduct electricity under certain conditions, and then sometimes it cannot conduct electricity.
Okay.
And then insulator is materials that are not very good at conducting electricity.
Mhm.
Yes.
So how can we protect ourselves? That's the question you raised, right?
Yes.
What's the answer?
If you want to protect yourself, you can use materials that is good insulators
Okay.
to be like in the middle between you and the electricity.
Okay. You finished?
Yes.
Okay. Give you homework. Let's go back. The resistance. How does it depend? Human body resistance. How does it depend on some parameters of human, like age, body weight, height, sex, these kind of things? Can you report in your report?
Okay.
Okay. Okay. Next.
So there are two challenges in our board game that involve with the
Hey, sir, what's your name?
My name is Poom Pakru.
Okay.
There are two challenges that involve with the object. The first one is called the mist, which is like the very dense of the fog. Have you ever wondered like why it is all blurry when it is foggy? Well, yeah, it's mainly because something called the light scattering. The fog is a tiny water drops, like a lot, floating in the air, and when the light that shine through the water drops, it cannot just like pass through. If you like hit the droplets, and then it will like bounce in different directions, and yeah, the bouncing make it is like harder to see, like all very fuzzy, and the color is like grayish. Yeah, and then there's another challenge that is called the illusion, which is like the mirage phenomenon. Like the mirage phenomenon can be explained by using Snell's law, where the Snell's law is all about like how the light will bend if the light go from one material to the another one, like from this go from air to water. So let's go back to our the mirage phenomenon. Like imagine like a very hot day, the road, the ground, the asphalt will be like very hot. So the air above the surface will be like very warm. But the air that stay higher up will like stay cool, like cooler than air above the surface. Even though it is like air, but for the light, it is like different because the light when goes from the cold air to the warmer air, it will like travel faster. So when it travels faster, it will like tricky for us to see whether the light is from the sky or from the ground itself. And let's go back to the formula. This n and then this like the reflection index is like each material has its own.
Can you skip basics?
Uh,
You have more material.
Budget no.
Okay. You guys need to go deeper, This is what you learned in high school, no? Rainbow, or you calculate a rainbow, okay? 1, 2, 3, 4, 5, 6. How does it work? Okay, what's the intensity from the first rainbow, second rainbow, third rainbow, and then you show intensity ratio. Okay, please do that. Okay, you need to be more serious. Okay, this is final presentation. I mean, what is this first page of the textbook? I mean, so most of you got a very low score today. So you guys need to be very serious about homework. Because if you're listening to the past weeks, other groups are presenting more advanced physics, right? I mean, it's not okay copy and paste high school textbook. That's not the final presentation of university class. So you need to be more serious. How long does it take to copy and paste this? 30 minutes? That's not good for final presentation. You don't get good score for like something like that. Okay, next please.
So next is thermodynamic. We need to understand.
What's your name?
Yeah, Ping.
Okay.
And then about so we see in the formula is P equal to K. K is the thermal conductivity. A is the surface of a thermal contact. Thermal contact, if we have a easy example, when we get cold, because during time is winter, and we're trying to use our hand, that we trying to make a heat. So your hand, yes, you get a heat, but in your arms, then you get, because it's no thermal contact. That is the A. And next is the differential temperature. It depends on the environment. Back to that example, it means the temperature or the weather right now and temperature that yourself have right now. This is the difference of the temperature. And next is the thickness of the material. We can see like in our sweater easily, it have a different thickness to prevent the heat loss that we can see. But actually, into the detail first, that how can we protect ourselves from the heat that we came back to go inside, go outside. Like, so firstly, we need to understand that if according to the formula to we get a heat loss, it means like if D is too much, it have a lot of D, it will be like the inverse. Yeah.
Can you skip basics? Do you have more advanced topics?
Okay, so the thermal conductivity, we know is someone will say in the textbook will say like you just find it as the material is. Actually, the K is not. K is can dependence. Is the the K can be defined as Q. Q is the power that the heat has transferred. With L, L is distance. And with the A, which is area with delta T. So we can came back that delta T we use in delta T. And we can predict that what is the K is. So first, if we see the organic things like wood, rubber, or another things that we can see in our daily life, we can have a less K that is not good to preventing the heat transfer things that we can have. But in the solid like metal, so we can see like hot pipe, we use copper pipe. So itself, because electron can prevent it and don't want the transfer of the energy go out, go in. That's why the copper can go into the electricity too. Like they trying to stick their electron, not just move forward into the outer space that it can conserve their energy inside. And these are all that are thermodynamic.
Okay, so the why rubber's thermal conductivity is very low? Why?
Because as we know, so the rubber is also it's let's say the electricity that trying to like not let anything pass. If we say the wood, like
Okay, so hold on. So freeze this thermal conductivity of all the materials you mentioned, and then explain why. Why copper has a high thermal conductivity, why rubber doesn't, and how different are they? Please try to explain the physics behind it. Okay. Every homework you do, I give you additional points. So, yeah. Okay, you guys run out of time, but then do you still have?
Okay, lastly is me to.
Okay, so you're the last one.
Yes.
There's no more. Okay, good.
Okay, in the event that we represent in the game, they're going to be like one nuclear
So
related.
what's your name?
My name is Napat Club. Napat in the Google Sheet.
Oh, okay. I found it. Okay.
So as you already know that nuclear is really harmful to your body, it may cause you cancer or like or contaminate in the air if like something happen. So
Why is it harmful?
because like nuclear is have a lot of radiation, and some of the radiation can contaminate in the air and into your body and make your body react in different way.
Okay.
Okay, so if something happened and then the nuclear is exploded, how can we like know that how big it is going to explode or something? We can calculate by the nuclear radiation by R equal to R0 A or powered by 1/3. So R is stand for the radiation of the nuclear. R0 is the constant rate of the radius of the nucleus, which is A is the mass of the nucleus itself. So, and we can also calculate the binding energy, that is the total energy of the nuclear reaction. And also there are by using the E equal mc squared from the Einstein. And next is the decay law, because like we also need to like make sure that after some time nuclear going to be disappear in the area, right? So this is the nuclear law where n equal to n0 multiplied by like E powered by negative lambda t. So lambda is like the decay constant of the half-life. So, but we can also use a lot of like energy that nuclear create by the nuclear pool plant operation. This operation have like basic detail that is fission. We made the fission reaction for the uranium and plutonium. This fission reaction will generate a lot of heat. We use that heat to boiling over water and then create the steam. And then the steam will go through the steam turbine to move it. And when it moves it, it will generate the kinetic energy to make the electricity. After that, we're going to cooling that steam so that we can reuse that water again. So some of the like basic equation is like how we to calculate the power. So the power of the nuclear reaction can be calculated by P equal to either QM. So P is the total power generated. So and also the EVA is like efficient of the power plant that you use.
You said nuclear fusion is from what elements? Nuclear fusion. You said nuclear fusion, right? From which element?
Uranium and plutonium.
It's wrong. So please correct in your report. Okay.
Okay, and then next is like to calculate, we need to find the Q, right? So the Q can be calculated by using the energy by is the same equation as like E equal to mc squared. And then lastly is like the rate. The rate is like using the energy product equal to like epsilon of like Q multiplied by Q, F and N, whereas the epsilon is the conversion energy, conversion efficiency. Q is the energy release per reaction, and F is fluids, and N is also the number of reaction per unit time. That's all.
Okay. What do you want to do? Okay, let's say how about this? So if you want to, support your Taiwan's necessary electricity, all from nuclear plant, how much materials you need depending on the type of the nuclear plant. So can you report in each type how much material you need? How about that? Okay.
I'll go research and say.
Okay. Okay. So you finished?
Yes, because
Yes.
our time is end.
Yeah.
So we
Okay.
don't
We
have
are
like play or like quiz.
Yeah.
Well, we don't have time.
Yes.
So okay. Well, like I said, you guys need to go deeper. Like, it's not good just report. Can you go back one slide?
Yes.
It's not just good to report. No, the next one. Then it'll be much better if you show examples with numbers that other people are doing, right? So this is just I don't know. Yeah. So okay, please do your good job. You still have a chance in your report, so please do good in your report. Okay. Thank you very much. And then I guess it's time to stop. So thank you very much for both groups. And then see you next week. Okay, online people, see you. Bye bye.
Professor, in the report, when we do the homework,
Yes,
we add the homework section as something separate or?
that'll be nice. That'll be nice. That'll be better.
Okay.
Yeah.
Okay.